Hey guys, it's day 4 of 100 days of DSA challenge, and today's question is of the medium level. It's Leetcode's 238th question, product of array except self. Well, the question is quite self-explanatory from the title. So you are given an integer array nums, and you have to return an array answer such that the ith element of answer equal to the product of all the elements of num except num's ith element. What does it mean? So for this input, I have to return an array such that for each element, the array contain the like if this is the current element, and I have to find out the element for it in the answer array, then I have to find the sum of all the elements except it. Okay, so for this it will be 2 into 3 into 4, that is 24. Similarly, if I have to find it for 4, then I have to find out the sum product of all elements except this element, which is 1 into 3 into 4, which is 12. For 3, I'll have to find the product of 1 into 2 into 4, that's 8. And for 4, I have to find out the product of these 3, that is 1 into 2 into 3, that's 6. So that's the output array. So this was the problem statement. You can see the test cases here. Alright, so now let's see how to solve this question. Well, the approach to this question is quite simple. I want you to pause and think about it before you see my solution, because once you see the solution, it's really easy to implement. Okay, so let's observe a pattern here. Suppose I have to find out the output for this particular element. Then I can do it. Okay, one thing that the problem statement has is that we cannot use the division operation. Well, why is that mentioned? Because if you use the division operation, then you can simply find the answer by multiplying all the elements and then just dividing it by the particular element you want the answer for. So if I want the answer for this 2, then I can just find the whole product, which is 24, and just divide it by 2. That's 12. But that is not allowed here, right? So what we have to do is we observe a pattern that if I have to find the answer for this element, then I can find it by finding the product of all the elements before it and finding the product of all the elements after it, and then multiplying those two elements. Okay, so for example, for this it will be 1, and this it will be 3 into 4, that's 12, and the product of both of these will be 12. So that's why we have 12 here. You can check it for any element. For example, for 3, it will be 1 into 2, 2, and 3 just 4 here, and that will be 4. That's 8. You can see it here. Alright. So we have to use this approach to solve this question. So to implement it in code, we will have two data structures. One will be called the prefix array, and it will contain the product of prefixes, and one will be the suffix array. Alright. Okay, so what these arrays will do, let's see that. So for each element, for prefix, we will iterate the array from left to right, okay? And for suffix, we will iterate the array from right to left. Alright, so let's see. So first we find the prefix array. So for prefix array, we will have it of the same size as nums, and we will find the product of prefix for each element, including the element. Okay, so for 1 it will be the prefix of 1 into 1. So what's that? There's no prefix of 1, so let's just say it's 1 here, a default value. So that will be 1, comma. Now for 2 it will be 2 times whatever the prefix here is. Okay, so basically 2 into 1, that's 2. For 3, it will be 3 into whatever the previous element of prefix was, that's 6. For 4, it will be 4 into whatever the previous element here was, 24. Well, why am I multiplying these with the previous elements? Because the previous element already contains the product of all these, right? So I should not waste my time calculating the product again and again when I already know it right in this array. So that's why we are finding it from here, right? So that's how we find this prefix array. Similarly, for suffix array, we move from right to left, as I said before. We move from right to left, and first we are at 4. So what are the product of prefixes? There's no prefix, so with there's no suffix, I'm sorry, there's no suffix for it, so we'll assume a value 1. 4 times 1 is 4, so that will be 4 here, right? For 3, it will be 3 times whatever the previous element was, it's 12, then 3 times 4. Then for 2, it will be 2 times, this is 24, and for 1, this will be 1 times 24, that is 24. So this will be the suffix element. Now let's see how this helps us to solve the question. Okay, so now we will take another array, ans, and it will contain our final answer. So ans is the array that we will have to return. It has the final answer. So how will we fill the elements in ans? We will use these two arrays that we made. So for each element, for example, for this element, I'll have to find the previous prefix element and the next suffix element from these two arrays. Like, so for 2, I'll have to find the product of this with this, and it will give me the answer. It's simple. So so let's fill it similarly. Okay. So now for this element 1, there's no previous prefix, so we will just have the next suffix element, that is 24, so we'll fill it with 24. And you know, this makes sense, it is right, because if you multiply all these and you exclude 1, you will get 24. So that means that our algorithm is right. So next we will find it for 2. For 2, I already told you, we'll find the previous this, multiply with this, we get a 12. Now for 3, the previous from prefix, next from suffix, multiply, your answer will be 8. And for 4, this previous, and next, there's no next suffix, so answer will be just this. So you can see that this matches our output array, hence our algorithm was right. So okay, so now let's see how the code works. So firstly, you just declare a variable n to capture the size of the array. Then you declare a vector integer named vector of type integer, name prefix, size n, all the values initialized 1. Similarly, suffix, and the vector of type integer answer. So now we will use a for loop to iterate through the nums, and we will fill the prefix array. And how were we filling the prefix array? So to fill the prefix array, we were simply, so for example, I have to fill the prefix array for this, right? So I just multiply all the numbers before it and then multiply it with this. Okay, so basically for this it will be 2 times the element before it, right? 2. This is not 0, I was just circling it. It was actually 1 here, right? So to find this, I just multiplied this with this. Okay, so similarly you can find the prefix of all, that is what I've written. So if this is the ith element, this is num's ith element, you're multiplying it with prefix I minus 1 element to find the prefix ith element. Pause it, hear it again, rewind, you'll understand it. what I just said. So that is what I've written. Prefix ith element equals to prefix I minus 1 into nums ith element. And there's an exception if I equals to 0. So if I equals to 0, that is this element, then there's no element before it, so I can't access it. So I can't say prefix ith minus 1 because it will say 0 minus 1, minus 1th element, and that is not defined. It will throw me an error. So that's why I've written this condition, that in this case you simply write the prefix ith element, that is the first element of the prefix, to be nums ith element. Okay, because I was saying we were multiplying it by 1. So it's the same thing as writing it like this. Then we have a for loop, and this one is to fill the suffix array. And we are moving from right to left this time. So that's why we are saying suffix I is equal to suffix I plus 1 into nums I. Try this out, write it on paper, or just rewind my video to the part I was explaining the logic, and you will understand this statement easily. And there's an exception here too. If it's the last element, n minus 1, if it's the last element, then there's no element after it, right? So it will throw me an error. So that's why we have taken a condition here, which is this. Now this is the final array to fill the answer. This is the final loop to fill the answer array, and we are simply iterating it, and we are saying if I equals to 0, then see these two are the exceptions. Let's see the main condition here. It's saying answer dot pushback prefix I minus 1 into suffix I plus 1. It's just what I said, that to find the answer for a particular element, you just have to multiply the previous prefix and the next suffix from these arrays, right? So it's just that. And now these are the conditions. If it's the first element, then I cannot say prefix I minus 1, so that's why I've just written suffix I plus 1. And if it's the last element, I cannot say suffix I plus 1 because that is not defined, so it's just prefix I minus 1. So that is how this code works. I hope you guys liked the video and you understood. If you still have any doubts, feel free to ask me in the comments. Thanks for watching.